All right, if you have not watched videos 1 and 2, you need to go back and do so. I just finished doing a rose curve, which I said had the form of A, the last one was a sine, but then K theta. There is a K, a period shift, no vertical shift, just an amplitude change. And so this is going to be a rose curve as well because it's the same form. Now, our K is 3, so our period is 2 pi thirds. That means that our period is 120 degrees long. So this is 24. I normally scale them by every 6. Since I need to fit 3 of them in here, I'm going to scale them by every 8. 8, 8, 2, 4, 6. How about this being 8? Yikes. 2, 4, 6, 8, 2, 4, 6, 8. There we go. We have no vertical shift, but we do have an amplitude of 2. And that's a cosine curve, which starts up. Now, the whole thing is going to happen in one period. So the whole thing's going to happen right there in 120 degrees. This can get a little messy when you do 3 of them. So what I typically do is dot in the others. I'm going to do this one a little bit faster. The difference between the last problem and this problem is that this one, the K is odd. We had an even K last time, so we knew that I told you that we had 2 times K number of petals. For this one, the number of petals is just K, so just 3. What we're going to see when we start graphing this is we're out here at 2, 0. So right there. If we're to go through, then we'd be at 0, 90, so we kind of, excuse me, not 90, 30. So at 30 degrees, we're here at 90, so we kind of look like that. Then we're at -2 for 60 degrees. So at 60 degrees, we're at -2 down here. Then back at 0. So what we've just generated is this. Looks like that. And then we've kind of gone back up to 0. And then back here for 120, we're out at 2 again. 2. So now we've generated that. It's gone through and gone whoop. Then we're going to come back down to 0. Then this is, let's see, 120 plus 60, so 180, we're at -2. So at 180, we're at -2. So we're back here. And so that's why odds, they start to generate themselves again, and they end up only having 3 petals. All right, last one. He is a limacon again because I noticed that he has a vertical shift and an amplitude. So his vertical shift is 3, amplitude is 3, so 4, 5. So we're up at 6 and 0. We're a sine graph. This one I'm going to scale by 3s again because it's a regular one. He's a sine graph. His tip is at A plus B, so 6. The dimple, or if it's a loop, it's not a loop, but A minus B is 0. When you have a perfect dimple at 0, oops, you can't see, perfect dimple at 0, this is called a cardioid because it's a perfect, cute little heart. All right, so let's start generating this. So right here, and some of these points are a little bit more difficult because we're going to have to figure out how fat we are down here, but you need to go through the points, generate all of them. I'm only going to do the big ones here. But it's symmetric over respect to the sine, so y-axis. Going out to tip of 6, 1, 2, 3, 4, 5, 6. Dimple is right at 0. And then its fatness here, this is 3, 180 and 3, 360. So 1, 2, 3, 1, 2. I'm going to cheat, and I'm not going to figure out exactly how fat it is over here. I really should. When you guys do it, you need to do that. So find the point where it is here and here specifically. Looks to be that, I mean, they're going to be approximate, about 1, 2, I don't know, 3-ish, 3.5, something like that. You guys should be able to figure those out though from these points right here. Okay, and that's called a cardioid when it's perfect. Oh, I just realized I didn't talk about the symmetry of this last guy. This is a cosine graph, so he's going to be symmetric over the x-axis. Take a look. He certainly is. Yay. Okay, bye.